I'm on to problem 13. Similarly with number 11, I'm going to approach this in two different ways. One of these is going to be so much faster than the other, and as I mentioned in problem number 11, a good student will be able to recognize the easier method and use the easier method rather than going the long way. They ended up in this problem giving us 4 different gibbons. Many of them are like scarves. They're not necessary. They were additional and we could have done without them. I'm going to, in the first video, this one, go the long way. I'm going to prove several triangles are congruent and then show the pieces are congruent because of that. In this case, they're only asking for those pieces. They want to show that FA is the same as IA. And if I'm trying to prove triangles are congruent to show their pieces are the same, the triangles that contain these pieces are FRA and IRA. So using this method, I'm going to attempt to show that those two green triangles are the same, and then it will conclude that these pieces are the same by CP/CTC. First given is that angles 1 and 2 are the same. Then they proceed to tell us that angle RFI, which is the entire thing, is the same as RIF, which is the entire thing. If you watch this entire video, I would encourage you to see the other video. It will be so much easier than this proof, and it might encourage you to start looking for simpler ways to solve proofs, because what I'm about to do is going to take quite a bit of steps, I think. This is given to us. Once again, I'm trying to show that these top triangles are the same so that I can prove the pieces are the same. Unfortunately, neither the green nor the red angle that they just gave me are those two angles in the top. So I want to actually show 3 and 4 are the same, which I'm going to be able to do by subtraction. So the green angles are the same as one another. The red angles are the same as one another. So if I take the whole thing and take away a piece that's the same, then the remaining part should also be the same. Please do not try to use subtraction unless you know that the pieces are the same. So in this case, I knew that the 2 greens were the same from step 2. I knew the 2 reds were the same from step 1. So I can do green minus red, and the blues will also end up being the same. I discussed this numerically with segments before, but if the greens were 40 and the reds were 15, then the blues would both have to be 25. I would just do 40 take away 15 gives me 25, and they would be the same size. I'm going to do that without numbers. Just say green take away red is equal to blue, and the blues are the same because both green and red were the same as one another. So I will say the green angle, which is angle RFI, take away, I'm going to call the red one angle 1 just because I don't want to save time, is the same as angle RIF, which is the one on the right, take away angle 2, which leaves us with the conclusion that the 2 blue angles, angle 4 and angle 3, are congruent. This is the subtraction postulate. The next thing, they tell me that RA bisects FRI. Students in my class are terrible at this. FRI is the angle at the top, and they tell me that this line RA came and it cut it in half. The logical conclusion would be that these 2 pieces are the same, so I'm going to have to do this in 2 steps. First, I'll say that RA bisects FRI, and then I'll say that these 2 angles are the same.